This video that I'm created is to assist you in running a t-test. For the assignment for this week, I asked you to create two sets of data, mock data, representing a test score that you want to compare, perhaps between two classrooms and two schools or whatever, probably the same grade. So in this example, I'm making up data for a math test. Pick a grade. It could be 4th grade, 5th grade, but they're both the same grade. So everything is pretty much similar except for the test scores. So the way we do that is you open up SPSS, brand new file, and go down here on the bottom left. It says data view and variable view. Start with the variable view. So up here under name, I put in math because I'll be comparing two different sets of math scores from one classroom to another. Let's say they're both 4th grade. So on one, you put in math, and the other one you put in scores. Don't worry about these yet. Okay. Well, make sure that there's scale here and scale there, but it should be there by default. So you have under name, math, and then scores. Okay, then you go to data view. Here's when you put in your data. Now, under math, you want to put in your two groups. You have two groups. So you have all the ones that are in, let's say, Mr. Smith's classroom. You're going to name those 1. All right, so I have two sets of scores, 10 scores per classroom. All right, so total 20, but it's 10 from one classroom, 10 from another classroom. So here's my first 10. That's from Mr. Smith, and 11 to 20, that's from Miss Jones. So the first classroom I'm going to code as 1. The second classroom I'm going to code as 2. Okay, so under scores, these are the actual scores. Now, of course, I'm making these up, but these are typical scores on a range of 0 to 100. So some kids got 100, some people got 90, one got an 85, and so on. They're realistic scores, based on experience. So now, after you put this in, go to Analyze up here. You're comparing means. Go to Independent Sample T-Test. Click that. Now here you go. I've already put this in, but let me put it back so I can tell you how I did that. So your test variable is going to be scores and then math. Your grouping is math. Okay? So you're going to be comparing test scores, but your groups are going to be between classrooms of math scores. So these little question marks, you have to tell the computer, you have to tell SPSS what they mean. And all you're saying is that you're going to be comparing two groups. So which one is group 1? Well, group 1 is going to be all the ones that have 1s on them. And group 2, those are going to be all the ones that I coded 2. Okay. Hit continue. And it should be good to go. Hit OK. And here's your output. So the money shot here is right here, where it says SIG. Okay. For the purpose of this assignment, this is the one we're going to be looking at. So we can go into what these other means, other results mean later on as we go on in the course. But for now, for this week, just concentrate on this one window in here where it says SIG, or short for significant. What you're looking at is the alpha level that we set on this SPSS by default is 0.05. So look at that number, and if it's less than 0.05, the difference between these two sets of data is significant. Okay, and so the number here is 0.043. It's under 0.05. It is significant. The difference between the two is significant. The reason we do that is because you can look at the two numbers and you can say ostensibly, well, there is a difference between one class and another, that therefore one teacher might be better than the other, or the teaching methodology that you introduce from one teacher and not the other is the factor that makes the scores different. But you don't want to just look at the numbers and say, it appears that these numbers are higher. When you do a statistical analysis, you determine whether that number is significant. And and indeed, in this case, it appears to be significant. So either one teacher is better than the other, or the the methodology that you introduced could be superior to what the other teacher was using. Okay, so that's the money shot right here. That's what I was getting at. Significance 0.043 is lower than 0.04, excuse me, than 0.05, therefore it is significant.